This is Stefan. This is one of the first videos. I talked about in the previous video about what if can create a game over the top, etc. But let's face it, we first have to write it. And that's not a problem. I mean, I love the code. And this is just a very zoom into very concrete stuff. Let me show you what I have so far. So this is basically a map, and it shows all kind of squares, and it shows you what I'm viewing at. So this is a vector of the viewing coordinates, and this is a vector of the drawing position where this viewport, like how I call it, which is like a window on the map, or a camera or something like that, that's looking at the map, and it's drawn from 0 to 0. So it's starting from here. It has exactly the width and height of the map. So that's why you see it full screen. And you can actually scroll around by moving the mouse to the edges or over the edges. And it makes it move around. And how it's done is using a listener or observer, which basically observes the mouse. And when the mouse is moving, it's creating events and mouse movement events. And there is a listener, which is called the drawable viewport mover listener, and it's listening to these events. And based on where the new coordinates of the mouse are, it's just going to update the velocity, like which way does the viewport has to go. It will update that. So when I go with the mouse down, it will say, oh, okay, you're going to the bottom of the screen, and that means I have to update the velocity downwards, and then it will multiply it by a move speed, like how fast should I go downwards, and then it will actually produce the downwards movement, because basically not the map is being moved, but we're moving around the camera, the viewport on the map. And when I go up, it's going up. But there's one problem here. The problem is I can go up and it will snap to 0 to 0. So it will not go over the edge. And it also won't go over the edge on the left. But it will go over the edge when I go to the right. This will take a while. But we can actually calculate how many pixels it will take, because I know how big these squares are. And I know how big the map is in this case. So let's just quit this game. So let's say the map is 64 tiles. And a tile is 32 pixels. So that means after 2048 pixels, we're at the edge of the screen. But we also have to subtract the width of the screen. So we do this. And let's say the width of the screen is 800 pixels. So that means after 1248 pixels, moving to the right, we have to stop moving. That's it. So that's what we want to do. And that the same goes for downwards. If we have a map of 64 tiles downwards, which have 32 pixel size of the tile, then we say, well, it's 600 pixels the height, then we should stop at 1448. But that's just details. It doesn't really matter how big the map is. So let's see some code. This code is a unit test, and this unit test is actually testing the viewport mover listener. And what it does is it simulates that events are being catched or emitted. That's the better word. And this is saying, oh, a mouse moved event occurred, and I'm listening to it, and based on that, I'm gonna do something with the drawable viewport, and that's the camera that's moving around. So this actually is something from Slick, the game library, and which is an interface mouse listener. And I've built an abstract mouse listener, so some stuff is always implemented or just empty, which saves us a lot of trouble. And this means when the mouse is moved, and we're only looking at the new coordinates, because we don't care about delta or whatever. When we say it's lower than 2, and 2 is just an arbitrary number, the 2 means how many pixels from the edge, so we can actually make a constant of it. We can say replace all occurrences, and we say pixels near border, something like that. And we can rename stuff as the way as we go. The more we learn about the code, the more we can change it. So when the new coordinate is at the amount of pixels near border or lower near the border, then we move left with the speed we initialize ourselves with. Now, then this means if you get at the screen width, which is at the right of the screen, at the right part of the border, then we go to the right. And if we are in between, we don't move to the left or to the right. So basically move right. This is like, this could be called stop moving horizontally, something like this. But it basically means move anywhere but with a speed of 0. So it means stop moving. So this will set the velocity, which is built in the drawable viewport, to 0. We also do this for up and down. So when at the top or at the bottom, then move up or down, or well, move down, or it could be up, doesn't matter, with the 0 velocity. So what is actually controlling then the edges? Because we saw we couldn't go over the edge at the top, we couldn't go over the edge at the left. How we did that is here in the drawable viewport. A drawable viewport has a method called update. This is called before rendering. This is updating any state. And this means, what is it doing? This is actually performing a move. And these are immutables. So this will produce this vector, this 2D vector with an x and y, will produce a new vector. So that's why you see this construction with an is. And we are constructing a new vector using the current velocities, x and y, and their move speed. But then we need to snap it. We need to somehow make sure it does not go over the edge. And that's what happens here. So here probably something will go, don't go over the right edge, and don't go over the bottom edge. Okay, well, I work with tests, so I want to write a test first that fails, and then I will write the implementation. The test actually goes all the way through this update, and it will read the viewing vector, resulting viewing vector, and do checks against it. So this is a test. To give you some background, this is a test about moving to the left and making sure we don't go over the left edge. This is saying, well, the listener receives a mouse moved event, and it's basically saying these are the old coordinates. This is x, this is y, this is also x, this is also y. These are the new coordinates. This is basically saying, well, we're at the left, and the y coordinate is anywhere but not near any border. So it doesn't really matter. This is like a number, but I'm making sure it's not hitting any border. And when that happens, we know the velocity will be increased to the left with the move speed we give. And the move speed is actually defined here. It's actually called scroll speed here, so it's perhaps a bit weird. We provide the scroll speed here, and we know it's 2. The scroll speed is 2, so we know every tick, every time we update and render the drawable viewport, it will move 2 pixels, if you will, to the left. Once we hit the border, of course. So that's what we are making sure of here. We're hitting the border on the left, and then we know every time we go through a cycle of update and render, we will move 1 or 2 pixels to the left. So this will move 2 pixels, then 2, and then another 2. Well, we know where we start because we initialized the test, the drawable viewport, with these coordinates, the initial viewport x and y, which are both 4. And these are all floating points of type float, sorry. So that's why I initialized it like this. But we know when it is 4 and we move to the left, I know I'm subtracting, and I know that every time I move to the left, it will subtract 2. So I start with 4, then it becomes 2, then it becomes 0, and the next update render, it should remain 0 because I don't want to go over the edge. So this will make it 2, this will make it 0, and this, if I did not do anything, it would make -2, and that's what I don't want to happen. I want it to be 0. So this is actually the what would cause the bug. So this is how I work. I have this drawable viewport, and I don't have any code. I just comment it out. When I run this test, this will fail. So I will run this test, and you see, X position moved over the edge. Expected 0. I did not expect it to go into the minus, but actually is -2, and which means this. Well, that's all great. And now I know I have to fix something, and I can re-enable this. And when I rerun the test, I have a shortcut for that. Then it will succeed. So that's what I want to do now for going below. Well, it doesn't really matter which test I use as inspiration, so to speak. So I'll just use this one. Stops moving up, in this case stops moving down, when at the bottom edge. Well, this is making sure we move up or down. This should be down. This is the x coordinate. We don't care about this. We're moving down, and we do care about that. And to make sure we go down, we have to be at the screen height, which means I'm just basically with my mouse sitting here. In this case, popping up the dock. Then I also need to know where am I at this moment, and how big is the map. So this is going to be a bit more. Requires a bit more information, because what do we need to know? We need to know the height of the map, which is in tiles, which we can translate to pixels. We need the height of the screen, and we need to know the position of the viewport. So these are the things we need to know, so we can make a test that is reproducible, so we can run it every time and know what goes in, what should come out. So at this first point, the height of the map, I have no idea in this test. Let's see what I'm doing here. So here I'm creating a drawable viewport. Okay, it's all nice and such. It has a viewport, And the viewport is a mock, which means it's just like, it's a fake object. It's not really a viewport. I don't see anything with the map here. Let's see, viewport. Ah, the viewport has a map. See? This one has a map. But we don't know anything. I don't think the map is... Here the map is used. But that's the only thing. So somewhere we want to say the map is this big and we're starting at this position. So basically what we're saying, we want to reinitialize the drawable viewport. We want to say, yes, this drawable viewport, but it will start here and here and whatever. So basically we want to reinitialize these in our test. I'm just going to put it in the test and then later see if I can make sure that I don't need to copy paste this around. But for now this should be okay. I don't know yet how to specify the height of the map. Where? Because we provide the map in the viewport, but the viewport is a fake object. So not really sure where to put it. But let's say that what we want is height of map is, do we even care? Well, I know the height of the screen. The height of the screen is by default, it's initialized in game. The height of the screen is here, 600 pixels. So what do I know? I know 600 pixels divided by 32 is like 18, it's almost 19 tiles. So what if I say the map is 20 tiles. So let's say the height is 20 and the width of map is, you know, the width is 800. Oh, well, it's 25. I just put it here for completeness, but we probably don't need it. Then we need the height of the screen. Well, I know that that's the game dot height of screen. And then I somehow need to initialize where this viewport will be, because the viewport is 800 by 600, because we saw that in the game. And this is where you begin to notice there's a bit of a smell in the code, because we don't see anything like that in our code here. I just know it is like that, and we probably need to change that soon. Anyway, we have a starting position, which is in this case 4, and this is also has a value of 4. But we want to be sure, we want to be in total control. So I want to start viewport x is 0, viewport y is 0. And I will provide these. Okay, so we're really starting at the top left. We know the height of the map is 20. We know that it has 19 tiles it can render. And we have a scroll speed of 2, I believe. Yes, it is 2. So we can give it a higher scroll speed, so we don't need as much ticks. Let's say we have a scroll speed of, we use 32 pixels, so it should be something like easily divided. Let's say it's like 8 or 16. So this is our scroll speed. Yeah, exactly. With that, we can actually, we say, okay, we will move down. And now we know the coordinates, because initially the value is 0, and that means the end of the screen, the bottom of the screen, is at 600, and this will fit because we can still put 600 18.75, so we are still within the height of the map because it's 20, the max height, so we can fit there. This will make 16, so it will make 16, 616, 616. We're getting there, but we're not there yet. Then this will become 32, 632. So now we are beginning to reach the bottom of the map, but we don't want to go over it, so we allow this one. But the next one should actually fail. This will make 48 because it's just moving 16 pixels, but we know we cannot go that far because the height is 20, so we can only go as high as 640. So what it wants to do is it wants to go to this, but it should be corrected to 640. But we can only go to 640 because this 600 is just adding the height of the screen. So that means the actually viewport Y should not go over 40. Make sense? But this is what we want to check. We want to make sure if we go down and down again and down again, that we don't go too much down, because then, because of the height of the screen, we will see too much, and then we paste it here. We want to go to the maximum of 40, and that's it. And we're talking about the Y position moved over the bottom. Let's run this. Let's see what happens. It fails, and it fails because it's 48. As expected, it will create 48, and there's no code yet making sure that it goes over the edge and corrects it. This is where things get a bit interesting, because we still don't use any height or width of the map. So this is just like basic scrolling, but taking the height of the screen into account. So now we're getting into the interesting stuff of where do we get this height from, and how do we make sure it is being used correctly. But just let's see how we go from here. Let's see if we can get a glimpse of how to proceed from the code where we fix all this positioning, which is in the drawable viewport. Here we have this viewport again. And this viewport has a reference to the map. So what an easy solution would be is like get the map from the viewport, if you could do that, then get the height of the viewport, and from here we can actually calculate how many pixels, and then we can actually, well, the rest we know. But the problem is we cannot get the map. So let's create this getter for now, and let's see how it goes. But there's something going wrong here. We can already tell, because we get the map and then we get the height. So we're getting like two levels deep. But for now, let's make it work. Then later we can refactor it. It's complaining because map So this is the height of the map. And then we do tile dot. And I'm a bit puzzled because there is a tile class and it has a width and height. So these are the 32 I'm talking about, 32 pixels. Right. Height of map in pixels. And we're going to do this one. And we're going to say, well, we know the viewing vector dot y, and we know the height of map in pixels. So how do we get this? How do we know we're going over the edge? Well, we can actually calculate it. What we can do is we can say height of pixels plus the viewing vector, get y. We can compare these. Oh, but we have to make sure it's an int value now. I'm going to do it differently. We know the maximum amount of pixels we can go on. So this is the total height of map in pixels. So all we have to do, we have to make this an int with integers, so we can easily do a get y. Oh. So let's just get the y. This is the pixels plus screen height. So we get the y coordinate and we do plus game.screen height. And basically, what this will do, this will do this 48 plus 600, which will be too high. This will give us 640. In case the map height is actually 20. But we assume this. So let's say this is 20 times 32 makes 640. Then the viewing vector y, at the third step, it will move us down 3 times 16, which is like 48 pixels, plus the height of the screen makes it 648. And we know this is bad. So we want to check if the pixels plus screen height is higher, is going over the edge of height map in pixels, then we need to subtract. We need to correct the viewing vector now, the y position. With how many? Well, it depends on how fast we're moving. So subtract is this minus. We just need that. The height in pixels. Oh, I'm doing it the wrong way around. The pixels plus screen height is more, so we subtract the height of a map in pixels. Now we know what to subtract with. Now we can say the viewing vector is a new vector. This is the x value. The viewing vector just has the same x. And it has the viewing vector dot get y minus, so we get back up. Let's see if this works. Run again. Whoa, something really breaks now. And I bet it has something to do with this get map. It does. And you know why? Because this, and I can prove it, because now it's failing at the same line. Why is because the map is now being retrieved from viewport, and in the test we use a fake object, and we use Mockito, and with lots of mocking frameworks where you do a get, or you call any method that returns anything, and you don't stop any value in that fake object, then you will get null. So this is basically just the behavior of Mockito. So if you want to see what I mean, if you run this in the debugger, then you will see the viewport is an object created by Mockito. And if you do get map, it will return null. As you see here. Well, if you do null with get height, then you know what you get is a null pointer. So what we want to do is we want to stop that. Stubbing is like you say to the fake object, well, if this method is called getMap, then return this. I don't care what you do, just return this value. So now we know what to do. For this viewport, we want to stop it. So we do Mockito dot when getMap is called, then return a map. And we don't want to create a real map because that would require us to do all kinds of stuff. Like if we go to the map, this is not a map like a hash map, but a map of the game. You see we need some factory and it has a width and a height. We're only interested in is width and the height. So there are two ways to do this. We can create a new, let's see, we can do the naive approach. The naive approach would be, we do just a new map. We just don't provide any factory, but we do know the width and the height of the map. And now it's complaining, what map do you mean? And I say, my game map. Let's see what this does. Let's run the debugger again. So here we see getMap now actually returns the map object we created. See, there's no terrain factory and it has a height and a width of 20 and a width of 25. Let's proceed. So it actually doesn't crash. I'm going to remove the debug statement and proceed. And it says test is passed. Go to the console. It actually passed. So what happens? What we can do is just add the debug statement here and run again. So here we see, and we can go back here and back even here, we can see at the third run, so the third time we update and render, we go to the update. Yes, that's of course the method. And then we get here, we move with this velocity of 16 pixels, and we move, the y has a velocity of 16, and the move speed is 1, so we do 1 times 16, 16 at a time. And now the viewing vector get y, and we can probably get this value from here now, is 48. Which makes sense, like 16 times 3. Then we add the height of the screen here, and we make 648. But we know the height, the total height, is 640. That's what we expected, and we can check it here as well. Evaluate 640. So now this is basically checking if it's going over the edge. If it's higher, then subtract it. Subtract it with how many? That's interesting that IntelliJ says this. It's 8 pixels too much. If we go here, it hasn't evaluated yet, so I have to do that first. And now it's saying subtract with 8. And now it's just updating the viewing factor with the y, subtracting with 8. And proceed. So now I'm going to remove all this kind of stuff. I know it. And this actually works. So we can remove all these comments. Now our test is saying, this is the height of the map, this is the width. We start at 0, 0, and we have a scroll speed of 60. We have 3 ticks. We initialize a bunch of stuff. We have 3 ticks. And then we want to know what the viewport factor is. And we want to make sure it's 40. So this is a magic number because 40, what's 40 what? So when I'm going to read this later, like something breaks and I have to figure out why this test is breaking, it is saying, well, 40. And I'm like, what does this mean? What we want to say is 40 is the maximum amount of, that y can be, given that the height of the screen is 600. So somehow we have to communicate that. So what we can do now to make it more explicit is we make a variable and we say the max y viewport position con. And this is already a bit better. We know it is 40, but let's take this out. It is 40. But what does it actually mean? I mean, it's 40 now. But what does it mean? It means that it is this gain screen height and minus, no, that's not true. What it means is the height of the map times the tile size the height of the tile size, 32 pixels, minus the gain screen height. This is the maximum position. The maximum position is, don't care how high the height of the map, I multiply it by 32. In this case, it's just 20. And then I subtract the height of the screen, and that's how far you can go. Now I can rerun the test. It still works. And this has become a concept. So this will now work, and I will stop this video, and I will, but not before I have committed. So I will commit first. So what we did is we returned the map, not really liking it, but for now, okay. We don't move over the edge. We rename something here. This has nothing to do with the change we're doing, so I'm not going to include it. This is included. This is included. This is not. This is also not included. And this is the test, making sure we don't go over the bottom. Make sure we don't go over the bottom edge or border. I'm always not sure which word to pick. I'm gonna commit this. So this works, of course, but the code can be improved. And we also had to do some state retrieval somewhere. We had to mock something here. This probably can be done better. And let's see how it goes next time. Next time I'm gonna refactor this, so the setup of the code will be moved more up, probably. I'm also going to make sure that we cannot go at the right edge or border or whatever, which is basically the same thing, but then for the X viewport position. And then we're going to look at some code and see if we can improve it. Okay, thank you. Bye bye.